Everyone. Today we are going to learn something about frequency distribution, in particular when we have what you call ungrouped data. So let's start. We are going to start with an example. First of all, if you look at the first bullet in the presentation, the definition is that frequency distribution table summarizes the values in our data in a way that one column will have the values that are included in our data, and we are going to have a second column which is going to have the frequency of the occurrence of each value. So we have a table that has two columns. One column is we fill in with our data values, and the other column we fill in with the frequency that corresponds to each value in our data. If you look at the example in this table in the second bullet, you will see that now we have collected this data from a certain hospital in the town, and we have collected data that about the number of children that are born in each month of the year from January to December. So we have this data we collected. As you can see, if you glance at this data, January, the number of children that are born in the hospital is 12 children. In February, you have 5 children. If you look at March and April, they both have 12 children. So we have kind of a repetition. So frequency distribution table is going to help us condense this raw data into a small table such that we are going to, for example, say that in the month of March we have 12 children, and in the month of April we have 12 children. So in this table we can take the values to be the number of children that are born, and for example, for 12 children we have 2 months. Of course we have 3 months. If you look all the way on the right, November is also 12 children. So for the value of children that is equal to 12, the frequency that corresponds to that value is going to be 3, because we have 12 children in 4 months. If you look, January is 12, March is 12, April is 12, and November is 12. So for 12 children, how many months? 4 months. So the frequency is the number of the months, which is going to be 4. Similarly, if you look the number of children that are 9, we have how many months? We have July, 9 children, October, 9 children, and December, 9 children. So we are going to say that the value 9 children, the corresponding frequency is 3 months, which is going to be 3. Now we understood a little bit about the value and the frequency of the frequency distribution table. Let us see how our data will look like when we apply this principle we just mentioned. So as you can see, we said in the previous slide that 12 children, the frequency or the number of months were 4. For 9 children, there were 3. And if you look back in the table and you count the rest of the months, we have 1. one frequency, right? So if you look February, we have 5 children. There is no any other month of the year which has also 5 children. So we conclude that for the value 5, its frequency is only 1 month, which is going to be 1. So this is the way we are going to uh, drive this short frequency distribution table that can summarize our data in its original format. So right now we have prepared the ungrouped frequency distribution table. It's ungrouped because each value in our data stands on its own. We are not going to create groups as we will see in later videos that will contain range of values. Now we have discrete values. So once we have discrete values in our data, we say it's an ungrouped data, and this type of ungrouped frequency distribution is appropriate when we have a small amount of data, like 15 values up to 20 values. If you have more than that, then we will see how to deal when we reach uh, grouped frequency distribution. So now we have this ungrouped frequency distribution table. What can we do about it? Because at the end of the day, we don't want to just watch this table for nothing. We need to extract some values, all right? So what we can do is we can run some type of analysis, especially when we have this small value of data or a sample. We are going to run what we call descriptive statistics, and we are going to analyze the average values. We have all these children for and it is frequency associated frequency, so we need to arrive at the median, the mean. So before we go to the mean, as you can see, the value of the number of values we donate using x and frequency f. So if you add all these values, the number of children you will get some summation or total x. That symbol is summation or total, which is going to be 72. So we have total of 72 children that are born for the whole year. And of course, if you add the number of months, they should equal to 12 because we have 12 months in a year. So we have sum of f or sum of frequency and sum of x or sum of values. Now let's define the mean. So the mean, is the average value of the data. We can give it this simple when we are talking about sample mean, like in our case, x bar is going to be equal to uh, the sum of x times f divided by f. Of course, x is the value in each row of our table and f is the frequency. So we have this frequency distribution table. We are going to add a new column on our table right now to calculate the mean. And here it is how it looks like. So we multiply each value by its frequency. So x times f. If you look at the first row, x is 4 and the frequency is 1. 4 times 1, on the right you are going to get 4. The second column, the value of x is 5 and the value of frequency is 1, so you will get 5, and so on and so forth. In each row of our distribution table, you are going to get x times f. Then when you finish for all the rows in our table, you're going to add them all and you are going to get now sum of x times f, and you will get, when you use your hand calculation or maybe your Excel software, whatever, 126. Now the mean was defined by this formula. So sum of xf on top is 126 and the sum of frequency is 12, and if you divide these two you will get 10.5, approximately 10. That means on average in each month we have 10 children. That's on average. That's the mean of one of the descriptive statistics we can analyze using our ungrouped frequency table. The next one is the mode and the median. Mode is that value in our table that has the highest frequency. Now, if you go back to our table a little bit, now which value in the first column has the highest frequency? 12, right? Because 12 has the highest frequency, which is 4. So the mode is going to be 12, as you can see here. The median needs a little bit of calculation. This is the middle value, but you have to arrange your data in either ascending, which means from lowest to highest, or descending from highest to lowest. And of course, when you order your data elements can be two types. You can have odd data or even data. So you have different ways of getting the median for the odd and for the even. For the odd, the median is the value that corresponds to n plus 1 divided by 2. N is the size of our data, and the size of our data is 12 because we have 12 months of the year. When you arrange the values and they equal and they appear to be even data, now the median is the average between these two numbers, n divided by 2, n plus 2 divided by 2. You calculate each value, then you find the average between the two. So in our example, n is 12 months, so n divided by 2 is 12 divided by 2, or the value that corresponds to the 6th position. And n plus 2 is 12 plus 2, which is 14, divided by 2 is 7th value. Because if you look our data, if you go back a little bit in our table, we have 12 months, so is it odd or even? It's even. So because it's even, we are going to use get the median using these two numbers. So n plus 2 is the 6th, n divided by 2, sorry, is the 6th position, 12 divided by 2, and n plus 2 divided by 2 is the 7th position. So now our data ordered from lowest to highest is like this. And the sixth position is the value of 9. The 7th position is the value 12. So you take the average of these two, not the positions, but the values, the actual values. 9 plus 2 divided by 2, that is 10.5. So also the median is going to be 10.5. Now we have learned how to calculate or analyze our ungrouped frequency table using mean, median, and mode. Those three calculations are called measures of central location. They always measure around the center of our data. As you can see, the median is about the center. The average is the central value because we are looking for the average of all our values. So you now know how to get the mean, median, and mode. Let's go to the next. This one is quartiles. So quartiles is percentile, or they are also called percentiles, and they tell us something about our data. So we have a data, and the quartiles, they tell us we have two types: first quartile, which is Q1, and third quartile, which is Q3. So the first quartile is the 25th percentile of the data that is the left of the median value, while the third quartile Q3 is the 750th percentile of the right of the median. So in our previous slide we got the median. The median is we got it to be 10.5, and it lies between 9 and 12. 10.5 lies around here. So whatever on the left started from this 9, is called the left of the median, and whatever on the right is called right of the median. So this is our data. We draw this bar or line. So everything on the left is going to be the left of the median because the median falls on this area, and everything on the right is called, of course, right of the median. So the Q1 is calculated on the left, Q3 is calculated on the right. So we say that Q1, if you want to find Q1, you can get it to be the middle value of this left part, and Q3 is the middle value of this right part. So we have 6 on the left and 6 on the right. So the middle is, of course, is the median. So you can, because right now our data is even, we have 6 values, you can use similar procedure we use it in the for the even data. So you find n divided by 2 and n plus 2 divided by 2. So the median of the left side is 8.5 and the median on the right side is 2 alif. Now Q1 is 8.5, Q3 is 2 alif. Now we define a new parameter which is called interquartile range, and is the difference between Q3 and Q1. So when you subtract, you will get 3.5. That's the interquartile range. Next, now we can also play around with the variation of our data, because we have data distribution to alif months of the year. We can look if there is variation in our data, which means if the number of children that are born are more in one area, in one side of the distribution than the other side. So that's the kind of looking at variance or standard deviation. Variance is also called dispersion, and it indicates how the values are dispersed or deviated from the mean. So the mean is the central. So how the value, are the values close to the mean or are they far away from the mean? That's what it tells in simple sense. So to calculate the variance, of course, the first step is each value in the frequency distribution table, subtracting it by the mean of the distribution. Then once you do that, you need to square then every x minus x bar. Value minus mean, you need to square. And that value is called deviation square. If you look at our table, in the previous table, we had 2 alif months of the year. So this is the 2 alif, the values, the number of children that are born from lowest to highest. In our previous slides, remember, we got the mean to be x bar 10.5. So the mean is constant for all of them. If you look the first row, for example, x minus the mean is 4 minus 10.5, you will get minus 6.5. Similarly, the second row, 5 minus 10.5, you will get minus 5.5, and so on and so forth. You do the same for each row until you reach the last row, which is 19 minus 10.5 is equal to 8.5. Remember, we said you have to square each value, so minus 6.5 squared is 42.25, minus 5.5 squared is 30.25, and so on and so forth. So once you get x minus, once you create that new column on the right, on the far right side, x minus x bar squared, now you can calculate the variance. The variance is, so x minus x square bar square, you need to add up all of these values on the last column on the right side. The deviation square, you need to add them all. So when you add them all, now the variance is the sum of deviation square divided by n minus 1. So if you add all these values, sum of all these values, you are going to get 187. Remember, n was 12 because our data was 12. We had 12 values for 12 months of the year. So n minus 1 is 11. Now the variance is going to be 17. Remember, the variance was calculated from deviation square, so it doesn't make much sense because if we are using unities, it will give us, for example, if our data was the mass of students, it will give us kilogram square. If it was height, it will give us meter square. So it will give us the unit of square, which is not meaningful. So to make it meaningful, we need to take the square root of the variance, and that will give us the standard deviation. So the standard deviation is the square root of variance, which is square root of 17, which is 4.12. So up to now we have learned, given raw data that is small, how to develop the ungrouped frequency table, then how to calculate the measures of central tendency like mean, median, and mode, and also the variation of our data like standard deviation. In the next lesson, we are going to look at how to do the same procedure, but now for grouping frequency distribution that has large number of values. Thank you.